Welcome to week 11. We're going to stay with chapter 11 here as the second part. S&OP is such a big part of companies today. I hope you picked up on last week's introduction to S&OP and aggregate planning that if you're not doing a good job at those two functions, then pretty good chances either you're getting way too much inventory in your system, so you're losing money, or you're not able to meet your customer demand, so you're losing money. So it's really a critical link in the system. We're also going to keep moving with our online simulation. We'll do simulation 3 this week. So our learning objectives haven't changed. We're just going to dig a little deeper into them. Our schedule this week's a little different because there's no Learn Smart, there's no quiz. So you see kind of 3 flows into this. One, we're going to do a skateboard assignment, which is an Excel spreadsheet that's already created for you to use. And I'll go over that in just a moment. There's an article for you to read and a little quiz to take associated with that article, and then simulation 3 and the optional discussion forums out there for discussion of any of the materials this week if you get stuck on anything. So we will do simulation 3 this week. It's the same simulation we've been doing. You'll make decisions across all 3 areas, receiving and procurement, as well as production, and then finally your shipping decisions. The big change this week, which won't be huge for you, is down here in current contracts, you have the option to reject contracts or accept contracts. So in that case, you'll be able to determine what revenue opportunities you want to take on. And then, of course, keep in mind that as you make your decision to accept a contract, then be sure to go back to procurement and order what raw materials you're going to need, schedule it into production, and make sure you're shipping your goods. You'll have 2 runs this week, and the highest score will count. All right, so what's been going on? This aggregate planning S&OP, it does begin as an intermediate planning, so 2 to 18 months. That's different from what we talked about a couple chapters back in capacity planning. Capacity planning is when you're actually building facilities, which is a multi-year commitment. You're really getting down to the kind of close to the nitty-gritty here, where you're deciding how you're going to meet the customer expectations, or what I call balancing demand and supply. The demand forecast is a really critical input to that, and so you need a reliable demand forecast. You need to go back and forth with the marketing department or sales department that is providing that sales forecast, and really deciding if it's accurate and validating it. And then once we're sure that that's a reasonable forecast to work toward, then we can look at how do we fulfill that capacity. And we do things like we can put inventory into the warehouse and have it sit there until the demand occurs. So if we have capacity available, we can make the products early. Or we can make them what we might refer to as just in time, so make them in the same period that we're going to actually use them. But we've got to balance those 2 out. And the nuance in production is that we might make them ourselves using regular time, we might make them ourselves using overtime, or we might outsource them. So those are the 3 primary ways we can generate units. And then the inventory option is we could generate those units early when we have time and let them sit. We see those with Christmas type items, where Christmas trees will be produced in the summer. Artificial Christmas trees will be produced in the summer and shipped and stored either at the store or in a regional location, and then they're ready for the Christmas season. So we don't have to wait until December to make Christmas trees. We actually will make them in the summer so they're ready to deliver. The cost of not having the inventory when the customer wants it is lost sales, or what we'll term as back orders. If we have too much inventory by either producing too much or storing too much, we encounter holding costs, or what we call carrying costs. That's the interest and the insurance and the taxes that we have to pay on inventory when it sits in our warehouse. Production costs are what we incur, and so regular production is when we produce units using regular time and not overtime. Then there's overtime production costs, which are a little higher. And then we might outsource the product to a third party and have them make it for us. And those are usually even higher than our internal costs. So what do? Kind of mentioned that. If demand is greater than capacity, we might have to go to an outsourcing option, or we might make it a couple months early and put it in inventory. If demand is less than capacity, then we might have to scale back and just make less units and not use our full capacity. So we're going to do a little exercise to try this out. Simulation modeling is a method to do this. It's very popular to be done in Excel. You're going to notice in the article this week that they talk about the perils of using Excel, so watch that. There are certainly better tools out there, but for our standpoint in a classroom setting and for a small company, there's really no better way to go than Excel. But it all starts with the forecast that needs to be validated. Then we can make decisions and we can model this. We can say, well, what if we make 100 ourselves and make 50 on overtime and then outsource 20? Or what if we make 120 on regular? So you can play around with different scenarios, different ways of satisfying that demand. But what we want to look at is what is our total cost of producing those units. And so that spreadsheet will model that. And I'll show you in just a minute how that spreadsheet will work, and that spreadsheet is available in Blackboard for you to just download and do your what-if planning. So it's called Skateboard. It's from the textbook. If you noticed, or if you need to go back and take a quick look at the Learn Smart Chapter 11, it's called Exercise 1 Skateboard, and it has the Excel spreadsheet there. Some things to keep in mind is the model's going to start with some things that are important. One is that your starting inventory is 0. So there are no skateboards sitting in the warehouse to be sold. You're going to have to make whatever you need to sell. The forecast is already provided, and it has been validated, and it has been entered into the spreadsheet. So don't change that. Your goal is to develop a plan that will satisfy that demand. So here's your parameters that you'll work with. One employee has been injured on the job, so regular production is reduced to 280. That's row 6 on the spreadsheet. I'll show you in just a second. Rather than hire short term, overtime will be used, but maximum overtime is 40 units per period. That's week. So the most you can produce on regular time is 280. The most you can produce in overtime is 40. Now you don't have to produce 280. You could do 220 or 100 or 0. Overtime doesn't have to be 40. Again, you could do 40, 28, 35, whatever you want, even 0. You can outsource production as much as you want. There is no capacity constraint on that. As you make changes to the plan, watch the effect on your total cost. And your goal is to develop the plan that has the lowest potential cost. Once you have what you feel is the best plan, upload that to Blackboard. Let's take a quick look at the spreadsheet. This is exactly what it is. All of the formulas have already been entered, and I encourage you to kind of click around the spreadsheet and take a look at those formulas. Don't change them. The forecast has already been entered. This is a validated forecast, and so we are trying to satisfy a demand of 200 in period 1, 200 in period 2, 300 in period 3. So you see there's a little bit of a seasonality to this schedule. You'll do this by entering quantities into the regular, that's regular time, straight time if you prefer, for each period. So each of those yellow blocks in row 6, you'll enter quantities. Now you noticed in the earlier comments prior, your maximum for that row is 280 per period. So period 1, 2, 3, 4, 5, 6. You can do 280 in each of those. You can also use overtime in each of those periods, but you know the maximum overtime is 40. You can also outsource or use subcontracting. There is no maximum on that, so you can do your entire quantity on that if you want. But as you mix up those 3 values, each period, down at the bottom, in the bottom right-hand corner in row 32H, there's your total, and that will calculate every time you make a change in the sheet. It will update. If you don't satisfy the demand each period, you will create back orders, and there's a cost to back orders. If you look in the center of the spreadsheet, there's something called the cost table, and it says for regular, each unit costs you $2 to make. For overtime, it costs you $3 to make. For outsourcing or subcontracting, it's $6 to make. So for each skateboard, there's your cost. The next cost on row 21, cell B, is $1. So each time you leave a unit in inventory at the end of the month, it's going to cost you $1 to sit there. But then it's available for sale the next month. If you fail to meet the customer's demand in a given month, you will create back orders or lost sales. They will cost you $5. And then those back orders will be fulfilled the next month. So they don't go away. You actually will eventually meet them, but they are expensive. And that's all calculated into your total cost in H32. So basically where the yellow is, you'll just play with putting different values in to see what works, and you're going to watch that total cost to minimize that number. This is a what-if analysis for what you've done back in EBTM 350 and 251. So some terms, you'll get to really experience some of these. Back order backlog in particular, level production, demand management, those type of things. So give it a shot and have some fun doing what-if analysis this week.